And we're on. Okay, good. All right. Hey, today we're jumping into a new lesson. Basically, it's called polynomials. Anybody know what poly means? Multiple. Well, three, multiple. Okay. Um, Poly means many. Okay. So let me do a couple things. Polynomials. We're talking about the number of terms that something has. Okay. We're a lot of most of what you're going to deal with today is a binomial. But let's talk about some definitions. Okay. What does mono mean? You may know. Mono means one. Please write this down on your paper somewhere. We're going to do some definitions. Mono means one. So monomial. Okay, there we go. Monomial. That is one term. And an example of that would be like 2x to the third power. Okay, that's one term. I know there's a 2, there's an x, and there's a third power, but it's one term. 2x to the third. Okay, when we're talking about terms, your terms are separated by plus signs or minus signs or parentheses or whatever, as long as they're separated. When they're squeezed together like this, it's one term. Okay, like the number 5, that's a term. The letter x, that's a term. Okay, 2x squared, that's a term. Okay, so all this stuff is terms. Okay, so mono is 1. You may know what 2 is? Huh? Dos. Okay, so 2 terms. Anybody else want to try? Dos is correct in Spanish. Bi, there we go. So here we go, binomial. A binomial has 2 terms. So an example of this, a binomial could be 2x squared minus 6. Okay, that would be 2 terms. My terms would be 2x squared, and then negative 6 would be my second term. Okay, if they ask you to identify what the terms are, it's basically just the numbers that are in there with the signs. Okay, positive 2x squared, and then negative 6. Okay, those are your 2 terms. Okay, what about 3? Trinomial. Good. Trinomial. Okay, trinomials have how many terms? 3 terms. Okay, this is kind of like we just got done doing quadratics. Yes. X squared minus 7x plus 5. Okay, that would be a trinomial. Okay, there's 3 of them. X squared, negative 7x, positive 5. Okay. Now, because of the ice storm not long ago, we're going to deal with adding, subtracting. Okay, and we're also going to do multiplying today. And somebody was like, well, are we going to practice adding, subtracting? The answer is yes, because when you're doing multiplying, you still have to know how to add and subtract. Okay, so we're still going to do everything today. Okay, but this is a lesson that we can very easily combine. What does poly mean? Many. Poly means many. Okay, poly goes with a lot of different things. Okay, like what is it? Polytheism. Who knows what polytheism is? Go ahead.
Isn't it when you believe in like more than one? It's like religion.
Yeah, more than one god. Okay, like people believe in like the Greek gods, like Zeus and Aphrodite and all the like belief in more than one god. Yes, okay, polytheism. Okay, that's a very, I mean that's something that does go on in this world. Okay, what else? Um, what about polygamy? What's polygamy? You may know what that is? More than one wife or more than one partner. Okay, more than one husband, I guess. But it's having multiple partners. Okay, polygamy. Okay, poly means many. Okay, so it's not just polynomials. It's talking about poly anything. Okay, poly means many. Okay, all right. Is everybody good? We got the definitions going. All right. So today we are going to add and subtract. Okay. Now where's my mouse? I saw it. There it is. Got to click. We are going to add and subtract. So let's start with this one. Maybe. There we go. Adding, subtracting polynomials. Underline the word like terms. Underline like terms, please. Like terms, right here. Addition rule. We're going to combine like terms together. The thing I love about adding and subtracting, it's basically just a matching game. All you're going to do is just find the things that match, okay? Let me ask you this. Does 5x and 3x match? Does it sound like it matches? No. Do they both have the same variable? Okay, let's define like terms. Some of you guys are nodding your heads. Okay, like terms. They're going to have the same variable. I'm going to put an S on the end because it could be more than one variable. Same variables, and it's also going to have matching or the same exponents. Same variables and same exponents. If it doesn't match perfectly, I can't add them together. It's kind of like if I told you to add all the red apples together and you have a basket of yellow apples. Okay, I can't add the red apples to the yellow apples. I want to combine the red to the red and the yellow to the yellow. Yes? What's 5 red apples plus 3 red apples? 8 red apples. So in terms of algebra, wouldn't that, what's 5x plus 3x? 8x. And if you notice, what did not change? The variable. The variable did not change. When we multiplied, we changed it. Okay, you guys remember that when we multiplied with a common base, we added the exponents together. When you're adding, subtracting, your exponent and your variables do not change. Please remember that. Okay, please, that is the part people are going to mess up on. These do not change. Okay, those do not change when you're adding or subtracting. When you're adding or subtracting, you do not change the variable. You do not change the exponent. If you're adding 3x squared plus 5x squared, it's 8x squared. Nothing changed on the variable or the exponent. We just added the numbers in the front together. Okay, is everybody with me so far? All right, let's talk about number 1. So we've got 5a squared plus a plus 12. And then we got plus 2a squared minus 3a plus 10. Now, this plus sign doesn't seem like a big deal, but it does matter. If it was squeezed together, like if I had this, 3 and then 2, what does that mean? That means you would multiply those two together. But since you have that plus sign in the middle, what does that mean I'm doing now? I'm adding. So that plus sign in the middle does make a big difference, okay? Now, so what I'm going to do is I'm going to combine like terms. I'm going to, this basically means I'm distributing a positive 1 in there. When you multiply anything times positive 1, does anything change? No. Okay, so we'll get to a minus sign here in a minute. You guys know what a minus sign on the front of a parentheses does. You know that. We've already talked about it, okay? All right, so here we go. We've got 5a squared. What matches over there? 2. Is it positive or negative? What kind of 2a squared is that? So it's a positive 2a squared. So what's 5a squared plus 2a squared? 7a squared. We done? Well, with that one, yes. Okay, so that one's done. So I've got an a here and I've got an a here. Yes? What kind of a is this? Positive or negative? Negative what? Negative 3a. So let me ask you this. What is 1 minus, remember there's a 1 there. What's 1 minus 3? Not 2. Say it. Negative 2a. That's 1 minus 3 is negative 2. Okay? And that part's done. So now I've got 12 minus 10. Yes? What's 12 minus 10? Positive 2. You don't necessarily have to stack them. I just showed it to you to show you what I was doing with the like terms. Okay? Everybody good? Yes, ma'am. Which one? This one? We did. We went 1 minus 3. Now, some people are going to say, well, I thought you said we were adding. That one was subtracting. Okay. 1 minus 3 is the same thing as 1 plus negative 3. Everybody with me on that? Okay, it's the exact same thing. Don't let that confuse you. Okay, we're just combining the like terms. We're combining the like terms with whatever the signs are. Okay, whatever the signs are is what we're doing. Okay, go ahead and do number 2. I'm going to pause the video. Go ahead and do number 2. Go. Before I pause the video, if it does not have something that matches with it, just drop it down and make it part of the answer. Because if it doesn't change, don't just get rid of it. Just drop it down, make it part of the answer. Everybody with me? Okay, go ahead and do it. I'll give you about 30 seconds. You know what? I'm not going to pause it. Go. Not that long. I'm just going to stand here and look cute. No? Okay. Yeah. Okay. Coffee. Happy juice. All right, somebody talk me through this. Talk me through it. Anybody at all? This is awkward. You ready to stand up here awkwardly while we're doing YouTube? Are there any? What are the matching terms, guys? 2a what? 2a squared and 3a squared. What's 2a plus 3a? 5a squared. Okay, so those are done. You notice this time I didn't stack them, right? This time I did not stack them. It's okay. You don't have to. I have, what is this? Negative 1, right? Negative 1ab and what? Positive 5ab. So I have negative 1 and a positive 5. If I add those together, what do I get?
4AB.
Positive 4ab. I got to pause the video because I got a phone call. And we're back. Okay, here we go. So what do we got? We got -1 and a positive 5, correct? What is that? Positive 4 what? Hey, what do they both have? AB, yes? Everybody with me? Now, I have a b squared and I have a -7ab squared. Do they match? So what do? I bring them down, keep them, and I just make them part of the answer. So I have a positive b squared and I have a -7ab squared. That's really it. If it doesn't match, there's nothing to combine it with. I just bring it down and make it part of the answer. And if you notice, all of these terms, a squared, ab, b squared, ab squared, they're all different, which means I can't go any further. I can't do anything else with that. And when we're adding, subtracting, it has to match. Everybody good on that? You just leave it like that. 100%. That is simplified. That's as far as I can go. All right, let's talk about this. What if we have a negative in the middle? What does a negative in front of a parentheses do? We did this before. We have done this. We multiply it. We distribute that negative, but what does the negative do on the inside? What does it do to all the signs? It changes all the signs. So if I have a negative, doesn't it change all the signs from positive to negative or negative to positive? You guys remember that? Because don't I really have a -1 here? Yes? And if I distribute, what do two negatives make? That is now a positive x squared. What is this now? What's this going to change to? A what? Negative y squared.
The one on the left stays the same.
Yeah. There's nothing over here. There is nothing over here. If I wanted to rewrite it, I could do this. Because now I can get rid of the parentheses if I really want to. If I want to, I can get rid of the parentheses. That doesn't change anything. Now I have a positive x squared and I have a negative y squared. You got? Everybody with me? What's x squared plus x squared? Say it. 2x squared. Good. What is y squared minus y squared? Nope, don't say it. Does it cancel? That's my answer. They canceled out. Basically, because what is 1 minus 1? 0. And then what is 0 times anything? 0. Basically just canceled itself out is all it did. Everybody good? Try the second one. Go. All right, did we distribute? What is that 8x squared now? So I've got negative 8x squared. I'm going to put it over here. I'm going to stack them this time. Yes? Just because. What's 10 minus 8? 2x squared. Those are done. Yes? Now, what does this negative 2x become? Positive 2x. So you should have ended up with positive 7x. Is that what you got? Everybody good? Negative or positive 7 becomes a negative 7. What is negative 6 plus negative 7? Negative 13. There's your answer. Everybody good? All right, let's jump to one more. We got one more problem at the bottom. I'm not going to skip over this. I'm not going to just blow this one off. Okay, I know that there are 3 different terms, yes? Can I give you a hint on this? Do the first 2 first. And then don't even worry about the third one until you're done with combining the first 2. Does that make sense? Don't try to do too much. Do the first 2, and then put the third one in there. Okay, ready, go. All right, what do we got? Let's do the first part only. I've got x squared plus x squared. What is that? 2x squared, yes? Done, done. What's next? I have an xy, and I've got a negative xy, right? So what is 2xy minus xy? Just positive xy. It's positive 1xy. Yes? Make sure it's in pause. Yep, we're good. All right, so those are done. Now I've got y squared and negative y squared. I see people shaking their head. What does that mean?
Take them out.
Yeah, they cancel each other out, yes? So the first 2 are canceled out. Or the first 2 are done. So now let's focus on the third one. Okay, everybody good? Negative, I distribute it. What does it become? Negative 3x squared. So I'm going to put negative 3x squared right here. underneath the other x squared. What is 2 minus 3? Negative 1, or just negative x squared. Yes? So that's done. Okay, then I distribute. The biggest mistake that you guys are going to forget is you're going to forget to distribute to everything in the parentheses. That's what's going to happen. You're going to forget to distribute to everything that's in the parentheses. Do not forget to distribute. Did anybody else forget that? I see people kind of smile. Yeah, yeah. I'm telling you, over the years of teaching, I see the same mistakes every single year. So I'm not surprised by it. So don't feel bad. Just fix it. Okay. Make sure you distribute to everything on the inside. Okay. So here we go. Negative 2xy becomes a positive 2xy. So what is 1xy and 2xy? Positive 3xy. Okay, so that's done. And then all I have left is a what? What does it become? Positive y squared. There's my answer. I'm done. One term at a time. Now, go ahead. What's your question?
Does it matter if you put negative 1x to it?
Mm-mm. I just don't like doing that because when you see it on a test, you will never see negative 1xy or negative 1x squared or whatever. You will never see negative 1. No. If you put it like if you show me your work, I mean, you did it correctly. Okay, but if it's a multiple choice test, you just won't see it. And I don't want it to confuse you. You're like, okay, why does this one not have a negative 1? Does that make sense?
Yeah.
Just make sure you understand the difference between them. All right, is everybody good? Okay. Like terms, tell me what is some key things about it? Go. Distribute what? The negative. What does the negative do when you distribute it? It changes all the signs. What are we looking for when we're talking about like terms? Same what? Same variables, same what? Exponents. Let me ask you this. Do these match? No, they don't match perfectly. Okay? For it to match perfectly, this would have to be over here. Does that make sense? So that would be 5x squared y. But if it doesn't match perfectly, you cannot combine them. Okay? Everybody's good, right? Cool. Let's flip the page over. Let's go to multiplying. Maybe. Huh. Oh, I forgot I clicked off the screen. All right. Multiplying. Like I said, normally we would stop right there and just call it a day. We can't do that. Okay, here we go. Multiplying polynomials. Now, I have it over on the other board. There were a couple problems, but since I'm recording, I'm going to show you guys this. If you have, I'm going to, just for the sake of backing up, or just for the sake of space, I'm going to move back one slide, okay? I'm still on the back. I'm still multiplying, okay? I want to show you an example. When I was in 7th grade, okay, Mrs. Pollard at Monroney Middle School in Oklahoma City, okay? This was 1990, 1991. Yeah, I'm so old. I was born in the 1900s, which is crazy. Okay. All right. We learned to multiply polynomials. She called what was called the George method. Okay. So, like, let's say I have x plus 3 and then x minus 5. Okay. And if I had this, I would do what was called the George method. I would take it and I would basically draw eyebrows. I would draw a nose and a mouth. Okay. So, let me show you this. Now, it's technically not incorrect. What is x times x? We would have x squared, yes? 5 times 3, that's negative 15. And then we would do the nose and the mouth. And I'll explain all that. See how it looks like a face? We called that George, okay? Now, I kind of like George. George was actually kind of cool. But the only time that George actually works is when you have a binomial times a binomial. When you put a trinomial in there, how many terms is a trinomial? 3. When we had a trinomial, it doesn't work, okay? Or some people did what was called the claw method, okay? Let me show you the claw, okay? The claw method was like this. Let me reset it. You basically take the first one, multiply it times that one, and you multiply it times that one. Then we take the second one, multiply it times this one, and then multiply it times that one. Makes like a little, almost like a lobster claw. Okay, we call that the claw method. I don't know if that's official. I call it the claw method. Okay, but what I'm telling you is it works okay unless you have a trinomial. So what we have is they have developed over time what was called the box method. Okay, the box method works whether it's a monomial times a trinomial or a binomial times a binomial or a binomial times a trinomial. Like, you can multiply all the nomials, all the polynomials, as many as you need using the exact same method, and it keeps everything very, very organized, okay? I love this method because it's very, very, very organized. I just like showing people George because if you take out the letters, you draw a little monkey face. Okay, George. Then you put like a little tongue down there. Okay. Anyway, okay, moving on. Sorry, squirrel, shiny. All right, here we go. Is everybody good? Is everybody good on this? All right, is everybody on this page? So we have a box method. We have x plus 5 and x minus 2. Now, if you notice this time, I don't have a plus sign or a minus sign in the middle of it, do I? I don't have the plus or the minus, which means now I have to what? I have to multiply them. Okay, so I'm going to take these two, and the box method, all I'm going to do is I'm going to take each one of these terms, and I'm going to put one across the top. So x and then a positive 5. I always put the sign. I always put the sign. And I'm going to put the other one down the side. X minus 2. What does this look like? Punnett squares. You guys are doing this right now in biology, aren't you? Yeah. It kind of works out well, like good timing. Okay. So Punnett squares, you had something like this. You had dominant, and then you had like a recessive, right? And like, so this would be like double dominant. Yes, I don't know the exact terms, but like you would have this. You guys remember that? You guys know what I'm talking about, right? It's the exact same thing that you're doing in biology, okay? Like this would be like, yeah, I don't know how it works, but then we have TD, whatever. I kind of sort of remember it, but I haven't done biology in like 20 some odd years, okay? But I do remember Punnett squares, okay? It's kind of the same information. It's the exact same thing, okay? So what we're going to have is we have x plus 5, we have x minus 2. Okay, so this square goes that direction, this one goes down, this one goes down, this one goes over that direction, okay? So let me ask you this. Now, what am I doing? Am I adding or am I multiplying? So you got to change your mindset a little bit. Now, this is where people start getting a little confused because you're used to adding now, and I just told you don't change anything. But now that we're multiplying, what do you do? What do you do with the exponents when you multiply with a common base? You add them together. We said that several times, didn't we? Now we're multiplying, so we're going to add them. What's x times x? X what? Squared. You guys remember that? Because that's the same as doing this. X to the first times x to the first. What's 1 plus 1? X2. When you multiply with the common base, you add the exponents. Remember the exponent rules test you guys took about 3 weeks ago? Where like, and then we had like a fraction and I could cancel them out. You guys remember those? Yeah. Okay. Just for the heck of it, let's back up a little bit. Remember x to the second times x to the third? What does x to the second mean? X times x, right? And what does x to the third mean? How many are there total? There's 5 of them, which is why I added these exponents together. When we multiply with a common base, you add the exponents together. You guys remember that now? You're kind of like, oh, okay, I'm kind of have a little flashback. All right, I see a lot of nodding, so you guys are remembering this. All right, here we go. What is 5 times x? Positive 5x. Okay, so that side's done. What is negative 2 times x? Negative 2x. And then what's negative 2 times positive 5? Negative 10. Now, let me stop you. Is everybody okay so far? Yes? Yes? No? Everybody's okay? Now, what do you notice inside this box? Are there any like terms? What are they? Negative 2x and 5x, okay? Now, so when I'm writing down this answer, what I'm going to do is I always start in the top left-hand corner, x squared, okay? That's done. I cross it out. Here's what I love about the box method. Your box method, 99.9% of the time, they're going to be like terms, diagonally. And all you got to do is just, now you're adding them, okay? And here's what I always do when I get started. I'm just going to, when I was first learning how to do this so I don't get confused, I'm like, I keep forgetting to add instead of multiply. You multiply, then you combine like terms. Everybody with me? So I make the big plus sign right in the middle is what I do. What is negative 2 plus 5? Or what's 5 plus negative 2? Positive 3 what? X. Those are done. What's left? I'm done. There's my answer. That's actually it. I'm done. That's all there is. Once you set up the box, it's actually kind of nice. It's nice and neat, and it's set up nice for you. All these arrows and stuff, I'm not going to put those arrows up there for you, okay? I just did that for the first example just to show you what we were doing, okay? Is everybody cool so far? Yes, ma'am. No, it doesn't matter. If I go negative 2 plus 5, it's still going to be 3. Or if I go 5 Negative 2 is still positive 3. It doesn't matter. It also doesn't matter if you put this one on top and this one goes. If you put the other one on top, let me show you this. X minus 2, x plus 5. Let me show you this real quick, okay? Everybody with me? X squared, negative 2x, positive 5x, negative 10. The only difference is these two are switched. It doesn't matter which one goes on top, which one goes on the side. It just flips the order in the diagonal. Yes, ma'am. Well, they wanted to do it like this. They want to go x squared. They want to do it like that. I always start in the top left-hand corner and just work your way down. Okay? Everybody good? All right, let's go to the next one. All right, 5x minus 1, 2x plus 1. Go. Let's put 5x minus 1 across the top so everybody's on the same page, just for the sake of notes. Okay? 5x minus 1 across the top. 5x minus 1, and that gives me 2x plus 1 here. It has to be down the side, and it has to be across the top. Okay? I guess technically you could put it on bottom, but that's just weird. All right, what's 5 times 2? 10 what? Nope. Right, 10x squared. Because there's two x's. Yes? We multiplied them together, so we added the exponents together. Remember, this is like x to the first, x to the first. Yes? What is 2x times negative 1? Negative 2x. When you multiply times negative 1, it's the same thing. Your sign just changes. Okay? What's 5x times 1? 5x. What's negative 1 times 1? Negative 1. Everybody good? Now, start in the top left-hand corner. What do you see? 10x squared. What is 5 minus 2?
3.
Positive 3. Positive 3x. So those are done. What's left? Done. You see why the box is nice? Kind of keeps everything nice and organized for you. Very convenient. Okay, do me a favor. I want you to try to do number 2. Go. See if you can figure this one out. Trying to pause the video, but I got a notification about Lainey Wilson, some kind of album. Okay, whatever. All right, did we get it? Hey, what do we got? Any guesses? X squared minus 49 is your correct answer. Why? What happened in the middle? They canceled each other out if you did it correctly. Just for the heck of it, I'm going to put the second one on top. Don't erase it. Don't erase it. Don't erase it if you did it the other way. Did everybody else put plus 7 at the top? Yeah. I did that on purpose. Okay, I'm obviously showing you this on purpose. The only thing that's going to change, we have x squared, and we still have negative 49 at the bottom. Yes? The only thing that's going to, when you do that, the only thing that changes is positive 7x. You guys probably have positive 7x in this box, right? And this one's negative 7x. Positive 7, negative 7, what happens? They cancel out. All you're left with is x squared minus 49. That only works with perfect squares. When you have negative 25, plus 5, negative 5, plus 3, negative 3, if you have negative 9. It only works with perfect squares, okay? Negative, give me another one. Negative 4, x plus 2, x minus 2, okay? The middle will cancel out because you'll have a positive and negative same number, okay? All right, let's do another one. Yes? Am I paused? Yep, I'm still working. All right, here we go. Let's do number 3 really quick. And I don't care which one you put across the top. Do not do number 4 yet because obviously there's no box there. But we're also about to multiply a trinomial. If you look at number 4. Nope, don't draw your box yet because... Nope, wrong box. All right, here we go. Let's do x minus 9 across the top. 3x plus 2. Again, if you did it the other way, not a big deal. The diagonals are just going to be flipped. That's all. Okay. What's 3x plus x? Or times x? 3x squared. Good. What is 3x times negative 9? Negative 27 what? X. Good. What's 2 times x? Positive 2. You don't have to put plus, but I'm going to just for the sake of, well, notes. Okay. Negative 9 times 2? Negative 18. Good. So start in the top left-hand corner. So let me go. 3x squared, done, minus 25x minus 18. Okay. It is a minus because the bigger number is in it. Negative 27 plus 2. Negative 27 plus 2 is negative 25. Okay. You're not going to mess up on the multiplying. Where you're going to make your mistakes is going to be adding, subtracting. That's where your mistakes are going to happen. Yes? Or you're going to forget an exponent. Okay. All right, let's do this one. What do you notice? 2x plus 1, then we got x squared plus x minus 1. We have a trinomial. And did I show you a box? Now, what we've been doing is a binomial. We've had 2 by 2, yes? 1, 2, 1, 2, yes? We've been doing a 2 by 2 box. Binomial, yes? But now we've got a binomial and a trinomial, so I'm going to show you how to draw this box. Now, you could either do it long ways or you could do it like this way. I like going this way. I like going sideways with it. So do me a favor, draw a rectangle. Put one line through the middle. Now, I like my lines to extend through the box, like out the edge. Wake up, please. I like my lines to extend all the way through so that I have like a little bit of a gap. Now, I need a trinomial. This is going to be my binomial. 2x and then a positive 1, right? So I'm going to put my trinomial across the top. So I'm going to draw 2 separate lines. Because now I've got 1, 2, 3 boxes across the top. It's always one less line. So if you need a trinomial, draw 2 lines. If you get 4 terms, you draw 3 lines. Okay. Everybody good? So now I've got x squared plus x minus 1. Do you guys want to try this one on your own before I even say anything? You want to give it a shot? Yes? No? All right, give it a shot. Go. Don't forget to add the exponents. All right, here we go. This first box, what should that be?
2x.
Nope. 2x to the power 3. Because if I add the exponents together, that's a 1 plus 2, right? 2x times x squared is 2x to the 3rd power. Correct? Is everybody with me? If you listen, you're probably going to make a mistake on this because it's the first one you've seen. Yes? It's fine. Just know what your mistakes are and fix them. How many of you have done this before? Exactly. Nobody's done this before, so I expect you to make mistakes. Okay, so don't feel bad if you're, cool. Fix it. Learn from the next one. Okay, here we go. What's 2x times 1x? 2 what? 2x squared. Okay. I hear, how many of you forgot the squared? 2. Okay. What's 2x times negative 1? Nope. Negative 2x. Remember, if you multiply times negative 1, it's the same thing again, just change the signs. And then what did I tell you if you multiply times 1? What is it? It's if you multiply anything times 1, what is it again? It's the same thing. It doesn't change. So I can take this entire line and just bring it down again. Would you agree? Because I'm multiplying times 1, so it doesn't change. Correct? Yes? All right. All right, here we go. Where did I always tell you to start? Which box? Top left-hand corner. What is it? 2x to the what? 2x to the power 3. Done. Add these. Plus, here's another one. I'm going to put a plus sign there because I want to add them now. What is 2x squared plus 1x squared? Positive 3x squareds. Yes? Okay. What is negative 2 plus 1?
-1.
Or negative x. What's left? Negative 1. There's my answer. Okay. How many of you got it right? 1. How many of you made a mistake, but you know where your mistake was? Majority of the class. I expect that. You want to try one more of those? Now that you kind of know what's going on? Can I show you a trinomial times a trinomial? Just for the heck of it? No. It's just a tic-tac-toe box. Looks like tic-tac-toe. Nobody? How many of you want to try that? Cameron? Let's do a binomial. Fair? Let's see. Is there any more? There's one more? Okay, let's see what it is. I don't remember there being one more. It's a what? Oh, no, it's not a monomial. What does x minus 4 squared mean? No? What does the squared on the outside mean? That there's two of them, right? So what goes across the top? Say it. X what? X minus 4, right? What goes down here? Same thing. This is the exact same thing as doing this. X minus 4, X minus 4. It's the exact same thing. A lot of people look at this. I promise you, a lot of people do this right here. And they say, oh, my answer is x squared plus 16. No, it's not. That's actually not correct. That is not right. Okay, go ahead and multiply that box. Go. Hey, we're almost done. Stay focused for me. We are almost done. Okay? Stay focused. Stay focused. All right. So what is x times x? X squared. Okay, what's negative 4 times x? Negative 4x. What's negative 4 times x? What's negative 4 times negative 4? Positive 16. So the x squared and 16 are correct, but you missed the middle term. Okay? Which would be x squared. What's negative 4 and negative 4? If I add those together, negative 8x plus 16. There's my answer. Pretty easy? Yes? Can you see where you can make mistakes on this very, very easily? Can you see? You can see where the mistakes are going to be? Okay. Please remember when you're doing these, double check your signs. That's where your mistakes are going to be. Your mistakes are going to be double checking your signs, okay? It's not going to be the process of multiplying. You're actually going to do okay on that. You're going to do okay on multiplying and all that other stuff. You're going to make mistakes when you're adding and subtracting. That's where you're going to make your mistakes, okay? Everybody good? Go ahead and take a little break.